Okay, hello. I would like to welcome you to our post-construction stormwater training. This workshop is being hosted by the Monterey Regional Stormwater Management Program. My name is Jeff Condit, and I'm the program manager for the Mr. Swimp. The Mr. Swimp is a collaboration of 7 jurisdictions along the Monterey Peninsula. You can learn more about our program as well as obtain access to our post-construction requirement supporting documents at our website, which is www.montereycsea.org. We are very pleased with the response that we have received from this training opportunity, and thank you for joining us today. Communities of Region 3 have been implementing the post-construction requirements since March 2014. These requirements affect how stormwater is managed on new and redevelopment projects. I first want to check in on the logistics for today. Today's presentation will run until noon. The training will consist of 3 parts. There we go. The first section will include an overview of the post-construction requirements, our stormwater technical guide, and other resources, along with submittal do's and don'ts for successful project review and approval. Following a short break, we will then present a case study of a recently implemented project and a dialogue between an applicant, a designer, and a plan reviewer. And then lastly, we'll have a Q&A section. We're aiming to allow plenty of time for question and answers. Participants can enter their questions throughout today's presentation in the chat functionality. There is a Q&A function, but please use the chat functionality. I'll be monitoring both, but we will attempt to get to as many questions as possible as time allows. We are recording today's workshop and we'll post the recording on our website following the presentation. With that, I'd like to turn it over to today's first presenter, Valerie Huff. Ms. Huff is a senior civil engineer at Wallace Group with a focus on all things water. She specializes in analysis and design of low-impact development, storm drainage, and flood control systems. Valerie was a member of the Joint Effort Review Team, working with regional board staff to develop guidance for implementation of the post-construction requirements, and was also a member of the San Luis Obispo Countywide Hydromodification Technical Advisory Committee, leading up to the regional board's adoption of the post-construction requirements. She holds a master's degree in water resource engineering from Cal Poly San Luis Obispo. I'll turn over to you, Valerie. Thanks so much.
Thank you, Jeff, for the introduction, and thank you all for joining our training today. I'm going to go ahead and share my screen so we can get started. And as Jeff described, I'm going to be talking today about the Central Coast post-construction stormwater requirements, which I will also refer to as the PCRs. I'm going to talk briefly about where the PCRs apply, who will need to comply with them, what types of projects, an overview of what the PCRs are, and then we'll spend some time on how to comply, some of the submittal do's and don'ts that Jeff was talking about. First off, I want to set up this presentation with a framework and a discussion of how the PCRs were developed. Now, the State Water Board issued a statewide stormwater permit, and within that permit, which is also referred to as the MS4 permit, they required post-construction requirements. Our Central Coast Regional Water Quality Control Board developed our local PCRs, our Central Coast post-construction requirements. And the regional board delegates the implementation of those post-construction requirements to the municipalities. And then they oversee design and construction through the development community. Now, the PCRs are the regulation. That is what was developed by the regional board. The municipalities have developed technical guides. Those are guidance documents that are intended to aid the development community. But if you have questions about the specific regulation, that's where you really need to go back to the PCRs. One of the first questions you need to ask yourself in post-construction compliance is, where is my project located? And for the PCR specifically, your question is, am I within an MS4 permit boundary? That's the municipal permit that was issued by the State Water Board. In general, the MS4 permit boundaries follow urbanized areas that are designated by the census. And so if you are within city limits or within an urbanized area, likely you are within an MS4 boundary. Check with your local jurisdiction to confirm if you think you might be in or out. Now, if you are within the MS4 permit boundary, now you need to follow the Central Coast PCRs. If you are outside of the permit boundary, there likely are other local requirements that may be similar to the PCRs. And if your project it disturbs over 1 acre, you will need to follow the state water board requirements for post-construction as a part of the SWIP program. Now, what I'm talking about today, what this presentation is on today, is for the PCRs, meaning projects that are within MS4 permit boundaries. Another aspect of location is where you are relative to what are called watershed management zones. When the regional board was developing the PCRs, they designated these watershed management zones, which then identify the specific requirements that your project will need to follow. So there's mapping for watershed management zones that is available on the regional board's website, and oftentimes in a link through the technical guides. Now that you've identified you are within the MS4 permit boundary, now let's understand what projects need to comply with the PCRs. In general, projects that create or replace more than 2,500 square feet of impervious surface need to comply with the PCRs. There are some very specific exemptions for project types, and I've listed the more common ones here. The first being linear utilities. So let's say you are constructing a new sewer or replacing a water line. Any trenching, any removal of pavement and replacement of pavement does not trigger post-construction requirements. Another is temporary structures. So if you have a structure that will be in place for less than 6 months, maybe some sort of construction trailer that is associated with your project. Any temporary structure is not part of the PCR compliance. And maintenance projects are not considered a part of the regulated project for PCRs. And there's specific criteria for maintenance. In general, maintenance of a street section means that you are not changing the way that stormwater flows. That's kind of your gut check. If you're changing the way that stormwater flows through regrading a street section or expanding a street section, now you are no longer falling under that criteria of maintenance. If you think you fall under one of these exemptions, it's important to go back and read through the regulation, the PCRs, and also confirm with your local jurisdiction that they agree with that exemption. Now, what are the PCRs? This slide is the post-construction requirements in a nutshell. And basically, the post-construction requirements have 4 different thresholds depending on the amount of new and replaced impervious surface that your project will create. The first threshold is site design and runoff reduction. And these are some basic measures that you can take to reduce the stormwater runoff and treat stormwater runoff on your project site. The second threshold, often called Tier 2 or PR2, Performance Requirement 2, is water quality treatment. And this is treatment of the 85th percentile storm. PR3 or Tier 3 is on-site retention of either the 85th or 95th percentile storm, depending upon what watershed management zone you are in. And threshold 4, PR4, is peak flow management. And this is matching your pre-development hydrology for the 2 through 10-year storms. Now, for PCR designation, there are really 2 project types. And so you'll see those 2 columns here in this table. The first is one single family home. And I want to clarify that this is very literally one single family home, a home under its own building permit. If you have a subdivision of multiple homes, you fall under the everything else category. So one single family home, everything else. Another thing to notice in this table is that some of the thresholds refer to what's called net impervious area. And let's talk a little bit more about that. So net impervious area is basically a credit specific for redevelopment projects. If you have a greenfield development, net impervious area will not apply. Net impervious area applies to projects where you have existing impervious surfaces, and through your project development, you will be reducing impervious surfaces. And I'm going to talk through this with a project example. On the bottom left was the existing conditions for a parking lot improvement project. This was a public project. It's a public parking lot and a building with some paving along the frontage that was all owned by the city. As a part of the project, we removed the building, we removed that frontage paving, and we replaced that with pervious concrete and a pervious paver walkway. So we had a net reduction in impervious area. The top right screen shows what the project site looks like post-construction. The existing impervious surfaces were approximately 21,000 square feet on the bottom left. Top right, the proposed impervious was 16,000 square feet. So we had a net reduction, a credit in the PCR terms of 5,000 square feet. Excuse me. Our new and replaced impervious surface, the total new and replaced was 9,000 square feet. And you might ask yourself, why is that less than the proposed? Well, there was a good portion of that existing parking lot you can see in the bottom left that we actually did not modify. There was a slight overlay, which was considered maintenance. And so our new and replaced, the asphalt and concrete that we actually touched or changed the way that water flows, it was 9,000 square feet. Now our net impervious for this project was our new and replaced 9,000 minus our credit of 5,000. So our net impervious area was 4,000 square feet, which made this a tier 1 project. And in my opinion, this was a win-win. It was a win for the city because it made PCR compliance pretty streamlined, and it was a win for stormwater because we reduced impervious area, we increased the amount of retention that could occur on this project site, and we improved stormwater quality. What is required for submittals for PCR compliance? During the planning phase of a project, you will need to prepare and submit a preliminary stormwater control plan. And the purpose of this preliminary stormwater control plan is to really prove out that your project can comply with post-construction requirements. You may have some simplified calculations. You may be relying on some typical cross sections, but you need to show a minimum amount of detail to prove that you can comply. And that level of detail is going to vary depending upon your type of project. So during that planning phase, you want to be working with your local jurisdiction to confirm that you are providing enough detail. Now, during your detailed design phase, your construction documents, you will prepare a final stormwater control plan. And this is where you will have complete calculations for all of your stormwater design relative to the PCRs, and that will correspond to all of the elevations, the inverts, the sections on your construction documents. At this time, you will also prepare a draft operations and maintenance plan to be submitted prior to construction. Now, during construction, there are specific inspections that are required to comply with the PCRs, and these are to document the construction of your stormwater control measures, or SCMs. And there's a certification that will need to be provided by the engineer of record that those inspections occurred during construction. Following construction, you will need to prepare your final O&M plan. This is based on record drawings and any changes that occurred during the construction phase. And at that time, you will also prepare a maintenance agreement. Talking a little bit more about the O&M plan and the maintenance agreement. The maintenance agreement is recorded with the deed. This lives with the project in perpetuity. The O&M plan is an attachment to the maintenance agreement, and the O&M plan is intended to be a living document, meaning that it will be updated over time and that annual certifications will be made to show that operations and maintenance is occurring on the project. That final O&M plan needs to outline your O&M procedures, your estimated annual cost for your O&M budget, and all of this needs to be recorded with the county assessor. What that means is that all of this has to follow the assessor reporting requirements of black and white 8.5 by 11. This includes the site plan that will be part of your O&M plan. So it's helpful to be forward thinking when you're preparing your site plan exhibits, to know that they need to be legible in black and white and on this smaller sheet size. In addition, following submittal of all of these documents, every year you will be required to submit a certification of maintenance to show that that O&M is actually being performed as described in the maintenance plan. Let's spend some time talking about how to comply. Now, I will be bringing up some of the common questions and some of the common challenges in PCR compliance. And then the subsequent presentation is going to go into more detail in some of these items and walk you through step by step the process of planning, design, and construction for an example project. First off, when you're starting down the path of PCR compliance, follow the technical guide. The technical guide that's the Monterey Regional Group has prepared and adopted a technical guide with the intention of assisting project applicants' compliance and also streamlining the process of plan review. So when you're following the technical guide, you have more surety that what you are providing is what is needed, and the plan checker will be able to more quickly go through your documents if they're following the templates and all of the information that is listed in the technical guide. What's shown on the right-hand side of the screen is a screenshot from the stormwater control plan template that's a part of the technical guide. And what I wanted to point out is that there's two different colors of text there. There's red text and black text. The red text is all guidance. So in addition to the technical guide itself, the templates also provide guidance on what needs to be included in each specific section. Every section in the stormwater control plan template is required by the PCRs. The PCRs have a detailed outline of what needs to be submitted for each project. And what that means is that every section of the stormwater control plan template should be included in every project submittal. There may be sections that are not applicable, and please just state that. Describe why they are not applicable. If you delete a section, likely during plan review, the local jurisdiction will ask you to put that section back in. So it will really streamline the process from the very beginning to include every section in your stormwater control plan that is included in the template. Along with the guide is an Excel-based calculator for the design of stormwater control measures. Now, the intention of this calculator is to be used primarily for sizing of bioretention features. That's what it's really targeted for. It will give you a volume that you can use for other types of features, but the primary use is for bioretention. A couple things that I wanted to point out on the calculator is that it requires input of your drainage management areas, referred to as DMAs, by surface type. And a drainage management area is very much like a watershed area or a tributary area that we would think of in terms of standard flood control. For the use of this calculator, you need to break out your DMAs by impervious and pervious surfaces. So when you're getting your input values together, keep that in mind. You also need to designate surfaces as either new or replaced. And this is important because there is a reduction factor for redevelopment projects that is built into the calculator. If you select that a surface is replaced, that reduction factor is automatically applied. And we'll talk through that in the next slide. The other thing to note is that one input is your rainfall depth for your design storm, typically the 95th percentile storm. The regional board prepared mapping of rainfall depths, and you want to be using those values unless there's a compelling reason, unless you can provide justification for using a different storm depth. So let's talk about that reduction factor for redevelopment projects. And this is intended to be a credit. It's intended to incentivize and really make compliance more feasible for redevelopment projects. And this multiplier is for tier 3 only. It's for on-site retention only. And what it does is it takes your replaced impervious surface and basically reduces it by a factor of 0.5. It cuts it in half. And so the volume that you need to retain on site is reduced compared to a surface that is new. And it's really important to understand that this is for retention only. If you are a tier 3 project, PR3 retention, you still have to comply with tier 2 stormwater quality. You have to provide stormwater quality treatment for all of the new and replaced impervious surfaces, even if you get this reduction for tier 3. I'm going to spend a little bit of time talking about DMAs. And again, these are drainage management areas. And one important thing that I wanted to point out is that DMAs can be different for different performance requirements. And what's shown on the screen here is an example project where that was the case. So this was a roadway widening project. This is an intersection where we were extending the roadway, adding curb and gutter, and in some places adding sidewalk. Over on the left-hand side, all of these colored areas represent new and replaced impervious surfaces. Those are the DMAs for PR3, on-site retention. Now, over on the right-hand side are the DMAs for PR2, water quality. There is a clause in the PCRs that requires water quality treatment for all surfaces, existing surfaces that cannot be separated from new and replaced impervious surfaces. And I'm going to just read this verbatim. Water quality treatment requirements shall apply to runoff from existing, new, and replaced impervious surfaces on sites where runoff from existing impervious surfaces cannot be separated from runoff from new and replaced. So this was a roadway widening. It's a crown street. All of these areas hatched in green are existing impervious surfaces that drain towards our new and replaced curb and gutter. Because we cannot separate them, now we're on the hook to provide treatment for those areas as well. So everything in green were DMAs in addition to the DMAs for PR3. And this project also needed to comply with PR4, peak flow control. Typically with PR4, you will have to account for on-site run-on, meaning any off-site areas that are draining to your project. So you may have DMAs that extend off-site for PR4 specifically. I wanted to point out that in some cases, your LID facilities can really be complementary to your flood control facilities. And this is an example of a smaller commercial site where we were able to use the same bioretention basins for both PCR compliance and flood control. And just wanted to point out that if you have the flexibility and it works for grading, this is feasible for some projects. And in this particular project, we were draining to these infiltration basins, which provided water quality treatment. They provided on-site retention, and these basins were connected in series through storm drain pipes, and they also provided on-site detention. So as each basin filled up, it would flow through the storm drain to the next downstream basin, until they all reached our site outlet down here in the bottom left. And we were able to take credit for all of the detention storage in the basins and in the storm drain system itself. Next, I'm going to spend a little bit of time talking about some basics of bioretention design. And this is a very schematic cross-section of a bioretention feature that's included in the technical guide. And I'm assuming that you are all somewhat familiar with bioretention, that this is a bioretention soil media, also called BSM. And below that is typically a layer of gravel. And the purpose of the gravel is to store runoff and allow it to infiltrate. And typically there's some level of ponding on the surface. One of the important things to note is that there should not be a filter fabric between your bioretention media and the gravel below. This is because filter fabric has been shown to clog in this use, and it can cause failure of your bioretention over time. And so in lieu of a filter fabric, you should be calling out for a small, a shallow layer of small gravel, like pea gravel. And the pea gravel basically holds the fines from the bioretention media from then infiltrating down into your gravel layer below. Another thing that this detail calls out is an optional orifice control. So this particular detail shows within the gravel layer, there's a perforated pipe. This is a 4-inch perforated pipe, and it's draining into more of a standard concrete drain and let box. This optional orifice control is called out as basically just a specific size hole that's been drilled into a threaded cap. Very easy to construct, simple to design because this orifice control is built into the Excel-based calculator. Now, the benefit of the orifice control is that it allows you as the designer to take credit for the storage in bioretention that is above the underdrain. So that orifice really forces water to be temporarily stored both in the media and even in this ponding area, and then it's slowly metered out through the orifice. So by using orifice control, you can reduce the required footprint of your bioretention basin because you're now able to account for the storage above your underdrain. This was a bioretention cross-section that I came across, and I wanted to use it as an example to point out a few things. First off, this is a different method of providing orifice control. So this is a riser pipe rather than a smaller diameter orifice. And what this does is that it forces the water to pond up to this height before it would fill up and then flow out of this riser pipe. Now, the downside to this is that really the only way for water to leave the basin below the elevation of this orifice is through infiltration. So if you are intending to use a riser pipe system, you want to have a lot of surety on your infiltration capacity of your soils below. So I would only recommend this riser pipe setup in more of a sandy type soil where you have a lot of confidence in the ability of your soil to infiltrate. Otherwise, below the elevation of this orifice, you could end up with ponded water, which could cause problems for your vegetation. The other thing that I wanted to point out is that this cross-section is showing some sloped area of the bioretention media here. Now, bioretention media by nature is loose, it's fluffy. It's meant to have a lot of pore space. It's not a structural soil. So you cannot count on this to be providing really any support to this native soil adjacent. Also, because of how loose and fluffy it is, it's really susceptible to erosion. And we saw that a lot in the storms that we got over this past winter, is that all of the bioretention basins I looked at, if there was sloping soil media, it generally had erosion. So we can't tell in this cross section where water is flowing into the basin. If there was a curb cut or something up here on the right, and there was runoff flowing into the basin, you need to design for erosion protection here so that that bioretention media isn't eroding away. If the water is entering somewhere upstream and it's flowing toward us in that photo, then this is probably okay. But it doesn't, the other thing I wanted to point out is that it does not provide benefit for your treatment area calculation. The post-construction requirements will specify, and this is in the technical guide, you need a minimum treatment surface area for PR2, water quality treatment. And there's a mathematical basis for this, but it's 4% of your new and replaced impervious area. And that's based on the intensity of rainfall and the design infiltration rate for bioretention media. If you have a sloped surface, this does not count towards your minimum treatment area, that 4% treatment area. You can only account for the area that's flat, where that water quality treatment storm is actually going to pond. One other thing that I wanted to point out here is the use of these drilled holes in the bottom of the concrete catch basin. And this is intended to prevent standing water. And it's a good practice because it can also now generate some more infiltration area. But one thing that I noticed is that really these drill holes in this catch basin are really kind of circumventing the purpose of this standpipe. So what I'm seeing is that any water that would be stored here in the media could make its way through the gravel, up through these drain holes, and now out through your storm drain. So this is a good idea and it's a good practice, but be intentional about where you use them relative to the location of your under drain, relative to the location of your bioretention feature. I'm going to spend a little bit of time talking about pervious concrete and pervious pavers. This is a project where we use both. So the parking stalls that you can see are pervious concrete, and the walkway down the center are pervious pavers, and both really have benefits and drawbacks. Pervious concrete, I'll say we've made a lot of good strides over the past 10 years in terms of standardization. But pervious concrete itself is more susceptible to failure because of construction methods. So I'll say it's more intense in terms of the specifications, the construction specifications, and also the actual methods of how it's constructed. One of the major design considerations for both of these types of surfaces is your aggregate storage below the surface. You will need to show through a calculation that you are retaining an adequate volume if you're using this as a stormwater control measure. And what that means is that you need to design your aggregate to hold that volume. Up on the top left shows the ideal condition where we have a flat site, a flat surface, we have this nice rectangular storage area. That rarely, if ever, happens. What usually happens is more like the bottom left, where you have a sloping surface and you have some level of storage before it's going to spill out of that aggregate layer. And two ways you can account for this are shown over on the right-hand side. So on the right-hand side, you'll see that while the pavement above is sloping, the subgrade is flat. And that is what is creating that storage volume below your surface. So now you have that rectangular storage volume that corresponds with your flat subgrade below. Now, if you're on a site with more slope, this can get really expensive because you may have a lot of aggregate subgrade that you're not using for storage. And so you can concentrate your storage on the downstream side by using more of an infiltration trench. And I've also seen this done in combination with something like this. So you have some depth, you will need some depth of subgrade, and then you get deeper on the downstream end. Now, the downside of this is that you've reduced your overall infiltration area. On the top right, your infiltration surface is that full length of your pervious pavement. And here you have a much smaller footprint. So something like this would really only be suitable for soils where you have a higher infiltration rate. And one way you can accomplish something similar, but still have a greater surface area is by using subgrade check dams, something that's going to help you create a stepped system where you're storing water and you have a larger area of infiltration. This is the more common type of pervious paver, where the paver itself is an impervious block and you're relying on the gaps between them to allow storm water to infiltrate. And you can see these little bump outs here. So the idea is that you push the pavers together and then the bump outs create the gap. It can be really tricky to place and construct these so that you're meeting ADA criteria. It's really intense for inspection to check that your gaps are not too big. Otherwise, you're no longer meeting ADA. And in addition to that, in general, that gravel surface, especially in the very beginning, right after construction, you're going to see some raveling. You're going to see some of that gravel coming out of those gaps. And you need to plan for this. This is expected, it's anticipated, but you need to have, you need to identify who is going to be responsible for the maintenance in the first few weeks immediately following construction, because you are going to have loose gravel. For these reasons, it's common that your local jurisdiction may not allow you to use these type of pavers for a surface that needs to be ADA compliant. And you may need to transition to a traditional impervious paver for ADA parking stalls and ADA paths of travel. Now, these are a great tool. They are part of a suite of pervious systems, and I certainly recommend them, but you need to think carefully about where you are placing them and how they will be used and how they will be maintained over time. Another option for pavers is actually a unit block of a pervious surface. So you can think of these as a block of pervious concrete. Now, so these pavers don't rely on a gap. The surface themselves are pervious. And so these are much more streamlined in terms of ADA compliance. I personally think they're better suited for projects within the right-of-way. And this example here is a great use for them, where they're being used over the root section of these street trees. And so they are allowing water to infiltrate right where the trees can benefit from that runoff. One of the common questions in PCR compliance is, what surfaces are considered pervious or impervious for threshold calculations? Remembering that all of the tiers of the PCRs are dependent on your quantity of new and replaced impervious surface. How do I decide what's impervious and what's not? And let's look at the PCR's definition. A hard, non-vegetated surface that prevents or significantly limits the entry of water into the soil mantle, as would occur under natural conditions prior to development. And that last part of the sentence is where the judgment comes in. Are you changing the way that water could infiltrate into the soil prior to development? If the answer is yes, then you're likely creating an impervious surface. Here are two really common surfaces where this question comes up. On the right-hand side is a decomposed granite parking lot. DG, decomposed granite, is crushed rock, and the mix is such that even when it's compacted, you still have pore space that allows infiltration. If you are constructing a DG parking lot or walkway, it's typically considered a pervious surface. If you are using a binder, the purpose of that binder is to hold together all the aggregates like a glue. It fills in all the pore space that allows for infiltration. And now you are creating an impervious surface. So with DG, it really depends upon how you're constructing it. Without a binder, typically pervious. With the binder, impervious. And always check with your local jurisdiction if you have questions on whether surface is impervious or not. On the left-hand side is a gravel driveway. And this is really a hot topic in our region right now. Our regional board is of the opinion that gravel surfaces are considered an impervious surface. And in particular, class 2 base, or any type of base that's well graded, meaning that you have a variation of rock sizes, because once a base such as class 2 is compacted, you have much smaller pore volume compared to, say, a typical soil. And that's because the fines and the different size rocks really kind of nestle together and create this solid surface. If you are designing a gravel roadway or a gravel driveway and you want it to be considered as pervious, the main takeaway right now is that you need to be purposefully designing it to act as a pervious surface. And that generally means an open graded aggregate. Some examples of this would be a number 57 or a number 8 stone, which are the same aggregates that we would use as a subgrade for a pervious pavement. Always check with your local jurisdiction to make sure they are in agreement. This is another common question about technical infeasibility. So this specific question was, if a site has high groundwater, less than 10 feet, and very poor infiltration rates, how does the engineer address PR3 on-site retention? And the answer is, this to me sounds like technical infeasibility. So the PCRs include a list of reasons why it may be technically infeasible to not provide on-site retention. One of those items is soil. It's item 3 in that list on the screen, sites where soil types significantly limit infiltration. The opinion of our regional board is that soil types alone do not prevent infiltration. So you may need to show more than one item on this list if one of the main reasons is soil types. Again, always check with your local jurisdiction. One of the items that I wanted to point out for technical let's talk first about what does technical infeasibility mean. If your site is classified as technically infeasible, this is specific for PR3 only, on-site retention. And if you qualify for technical infeasibility, what this means is that you're no longer required to retain a specific volume. You do not have to show volume-based calculations to meet PR3. You have to show area, surface area-based calculations. And there's a variable called the equivalent impervious surface area, EISA, that's defined in the PCRs. And what this is it's 100% of your impervious surface and then a factor of your pervious surfaces that are listed in the table. That's your total EISA. And you take 10% of that, and now you dedicate it to a retention-based stormwater control measure. Let's use bioretention as an example. If you are using bioretention, you no longer have to show a specific volume. You no longer have to store a specific volume below grade. You no longer have to run any volume calculations for PR3. You have to show that 10% of your EISA is dedicated to bioretention, and now you've met the criteria for on-site retention under technical infeasibility. And to wrap up technical infeasibility, I wanted to point out one of the more common reasons that I see for a site to be claimed as technically infeasible for on-site retention, and that's concerns with slope stability. So this is a project, a rural roadway widening project that we recently worked on, and you can see in this photo that the edge of the road is already very close to this existing slope face. And when we were on our site visit, what we noticed is that there were a number of rodent holes, a number of ground squirrels that were burrowing from the top to the bottom. And I have seen firsthand sites have, slopes have failures because of water piping through rodent holes. So if your project is within any proximity, even a few hundred feet of a slope face, you need to be working really closely with your geotechnical engineer to decide if your site would be classified as technically infeasible for PR3. And we did that for this particular project. All right, next, another hot topic of infiltration testing. So some of the common questions are, what's the difference between infiltration testing and percolation testing? How would I test for a surface stormwater control measure as opposed to a subsurface measure? How do I interpret test results? What are some appropriate factors of safety? What do I do with multiple tested infiltration rates? And what are some resources if testing is not performed? On the left-hand side is a schematic that shows the typical testing that would be performed in our region. If you're using the guidance that's on the regional board's website, you are performing a percolation type test. This test has a lot of benefits in that it uses the typical equipment that would be on site already for a standard geotechnical field investigation. It can be performed relatively quickly, and it can be performed at depth, meaning that it's important to be testing your soil at the depth where you will be infiltrating. And in general, using bioretention as an example, you'll be at least 4 feet below existing grade. You typically have 6 inches of ponding, 18 to 24 inches of media, another 2 feet of gravel. That means the base of your facility without any other surface grading is probably at least 4 feet below grade. And that really corresponds well with the typical depth for your percolation test. Now, the downside of the percolation test is that it does not correlate directly to a design infiltration rate. And here's the reason why. In general, in any soil profile, water is going to move faster horizontally through the profile than it will downward. Your primary method of moving water out of your bioretention facility is downward through infiltration. Your percolation test has much more sidewall area. This vertical area of the borehole is much greater, and therefore you have more horizontal movement, which is likely going to overestimate your total infiltration capacity. And let's look at this with some numbers. So I ran an example with a typical percolation type test, a 6-inch diameter borehole, 3 feet of standing water. Your sidewall to base ratio, meaning the surface area of the sidewall of your borehole compared to the surface area of that bottom 6-inch diameter, is 24. You have 24 times more sidewall area where that water is going to be moving horizontally through the profile. Now let's look at a smaller size bioretention. For a 4-foot wide and 6-foot long bioretention feature with a standard 2-foot gravel depth, your sidewall to base ratio is less than 2. Now, as your bioretention facility gets bigger, this ratio is going to go down. This is pretty small. It's a modest size basin. Now, if you're talking about a standard retention or detention basin that's vegetated, your sidewall to base ratio is going to be even smaller. And so you are vastly overestimating the amount of horizontal movement through your soil. So what's the solution? The percolation test has some great benefits. It's a good test. Let's continue to use it. But you need to mathematically translate your percolation values into an infiltration rate. And that's done using the Porsche method. So the Porsche method is basically a geometric calculation where you're taking the area of your borehole, the depth of your water, you're accounting for that horizontal surface area and translating that into a vertical infiltration rate. And really the thing to know here is that your geotech needs to be taking measurements of these values and providing them to you as the design engineer so that you can run this calculation. Lastly, on the type of infiltration testing performed, percolation testing is really well suited for subsurface infiltration, where you're relying on a gravel layer or you have a subsurface facility like an underground tank. If you are designing to infiltrate at the surface, such as this bioswale over on the right, you may get better testing results by testing at the surface. And that would typically be done with the double ring infiltrometer, which is shown over on the left. So what the double ring infiltrometer is doing is it's creating this saturated zone around the center. And the center is where we're testing the rate of vertical movement of water through the soil. Now, by doing this at the surface in a vegetated facility, you're really gaining the benefit of the interaction of the soil and the plant roots. In that soil shown on the right, the tree roots, the roots from the vegetation are all going to increase pore space and give you a better infiltration rate. If that's what you're designing for, take credit for it. And you could do that in some cases with this double ring infiltrometer. Now, the calculator has standard rates that are built in if you're not doing on-site testing, and these are based on hydrologic soil group. So there's a drop down for either A, B, or CD type soils, and then the calculator will automatically apply these infiltration rates. And these are always available to be used. You can, so if you don't have on-site testing, these values can be used in the calculator, and they are intended to represent a vegetated surface. If you have some other type of stormwater feature, check with your local jurisdiction to see if these rates would still apply. There are also safety factors that are built into the stormwater calculator, and a safety factor of 1 is applied for bioretention, and a safety factor of 2 is applied for direct infiltration. So here there's a drop down for SCM type. Once you choose your type, that safety factor is automatically applied. The safety factor of 2 means that you're cutting your design infiltration rate in half. The safety factor is 1 for bioretention because the purpose of the mulch on your bioretention facility is to capture the sediment that could be flowing in and reducing your infiltration capacity over time. So if you are adequately maintaining your bioretention facility, removing sediment, removing mulch, now you're providing long-term viability for that infiltration rate. Another question that comes up is for underground retention. If underground chambers are used for PR3 for on-site retention, can they also be used for PR2? And is pre-treatment required? Now, PR2 can be achieved on a volume basis, meaning that you can infiltrate water on your site, and now you're counting on the soil to treat your stormwater as it's infiltrating. So yes, absolutely. You can use these chambers if they are allowed on your site for PR2, and pretreatment is required. This is a sentence specifically from the Monterey Regional Technical Guide that says facilities with subsurface storage require permanent structural pretreatment. So the answer is yes. And here are some resources that I wanted to share with you. These are some of the most common resources that I use when I'm going through design of post-construction stormwater features. And with that, I am closing my presentation. We are going to hold questions to the end as Jeff described. We are going to take a quick break. We'll come back with the second half of our presentation, and then I will be available for questions following that. Thank you.
Great. Thank you so much, Valerie. That was a wealth of information. We really appreciate that. And as you mentioned, yes, we will have a chance for questions and answers after the next case study presentation. We are going to have a 5-minute break right now. We're actually ahead of schedule. Great job, Valerie. And so that'll give us more time for Q&A. So with that, quick 5-minute break. Thank you. Oops. Hey, welcome back. Following the brief break. Next, we are going to dive into a case study portion of our training. And I'm pleased to introduce our next speakers. Tricia Wotan is the Environmental Regulations Manager for the City of Monterey. She's approximately 23 years of professional experience in water resources science, engineering, consulting, research, watershed and floodplain management, city planning, CEQA, environmental regulations, including municipal water quality regulations for storm drainage, and sewer collection systems. She manages regulatory permits, programs, and projects for the city, coordinates development and implementation of those programs, and enjoys collaborative opportunities and partnerships to learn from one another and create streamlined approaches to help local agencies meet compliance goals. Nathaniel Milam is a senior engineer at Whitson Engineers, a local civil engineering firm located in Monterey. Nathaniel has worked on all types of projects that are subject to the PCRs, with a focus on street reconstruction, pedestrian accessibility projects, and on-site development for local agencies, for multifamily housing projects and healthcare facilities. With that, I'll turn it over to Tricia and Nathaniel. Thank you both.
Thanks, Jeff. Let me share my screen. Okay. All right. As Jeff mentioned, I'm Nathaniel Milam. I will be speaking today from the perspective of the applicant's engineer.
And I am Tricia Wotan with the City of Monterey, and I will be speaking from the perspective of a local agency. And I will just share that this is just one local agency perspective. Certainly, if you have any questions on what we shared today, please do be sure to check with your local agency for your project.
Okay, thanks. So today we're going to work our way through development of a real project. This will let us speak to some of the complexities of how projects are developed in the real world and some of the lessons that we have learned along the way. Just a quick disclaimer, since we are going to walk through a particular, even though theoretical project, we're not going to cover every situation. Some of the things we discuss are going to be particular to this project, so it's not necessarily going to be universally applicable to every project in every jurisdiction.
Great. And as we walk through sort of a project development workflow today and the examples and the hypothetical, we'll also be touching on, and actually that process is primarily driven by the local agency review process. So Valerie had touched on this earlier, but typically there's a planning application or discretionary review and approval phase, a building application, plan check, ministerial review phase, the construction phase, and then the project in perpetuity of that built project. So within all of those phases, there are different milestones for the PCR program and the documentation that the applicant should be submitting for our review.
So we'll start at project conception, walk through the project timeline, planning, design, construction, and utilization. Within each of these steps, there are a multitude of smaller steps, which in an ideal world, we complete in a stepwise fashion or a linear fashion. We all know that that is not the case. We do not do the project completely linearly. We do need to revisit decisions, redesign things along the way. Unfortunately, I'll just flag due to time limits, we are going to walk through this in a linear fashion. So it may not appear from our presentation that we did have to do a lot of reworking and redesign during the project, and we didn't hit many roadblocks. I'll just throw it out there. We did. We're just presenting this project in a very streamlined manner. So I just wanted to encourage you when you do hit roadblocks in your design, that is commonplace. So this is the project site plan we'll be going through today. It is the redevelopment of an existing 2.4 acre commercial site. In this example, when I was brought in as the civil engineer, the architect and the owner had already developed this concept plan. Part of their evaluation included whether to remodel the existing building or demolish it and construct a new building. They chose to construct a new building. The owner at this point already has his preliminary pro forma. So that's his preliminary scope, schedule, budget. This is what we all think when we're at this stage of the process. Unfortunately, things get complicated as we move through the project. The devil is in the details. Tricia, yeah, you want to take it?
Sure, you bet. So some reflections on that just upfront project conception phase. It's super helpful to really get a good feel for the basic metrics of your proposed development project, the location, the size, the development type, so that when you do have questions or you'd like to come to a counter at the local agency, you'll have enough information for us to be able to talk through that. So do make sure to gather as much regulatory info, utilize the resources and guidance Valerie's talked about and we'll talk about today. And then please do, if you still have questions after reviewing all of that guidance, seek guidance early, I would say, because if we can meet, if we can have pre-applications, and if we can have a counter discussion, that will help streamline the entirety of the development review for PCRs through the rest of the project's workflow at the local agency.
Yeah. Yeah. So just to reiterate Tricia's point, I find pre-application meetings to be very helpful, just to get everyone's eyes on it and have everyone be able to kind of see the things that they are expecting and that they may see down the road based on a very preliminary site plan. Also outreach, such as this, for architects and planners especially, are very helpful, because frequently they're the first ones to start looking at a project with an owner. And then I'll just also flag the building size and site layout are frequently already essentially set at this stage. Now we move into the planning stage. This is really where I, as the engineer, and Tricia, as the reviewer, start to really engage in the project. These are the questions that we are going to need to answer. I'd like to give a huge shout out to the authors of our stormwater control plan template. The way it's set up, the stormwater control plan walks the designer, that's me, through the decision-making process with the most basic and fundamental questions up front before we start getting into the meat of actually designing the stormwater control measures. So I appreciate the implicit reminder in the template that we need to go through these questions before we just jump into design. So again, this is our site map showing the limitations that have been identified so far. That's by the owner and the architect. The other things that are on my radar but are not shown: general site grading, site drainage, utilities, pedestrian access, fire department access, slope restrictions. So this slide shows my preliminary thoughts on those items. So now at this point, we've got a preliminary site plan. We can start walking through the stormwater control plan to determine what post-construction requirements apply and what other permit requirements are going to apply. We're going to walk through this slide and the next dozen slides rather quickly. I kind of consider these checklist items. In real life, I do go through these very quickly. Even though they are checklist items, though, I would say it is important to go through them so that we can flag if there are any items that need further attention. So watershed management zone 1, we've got way more than 22,500 square feet of impervious area. So we've got all the PCRs applicable to our project. I met with Tricia. There are no other local agency requirements for our project. The only other permit is a SWIP because of the size.
Yes, and I was just going to say here how important these watershed management zone determinations are to know up front, especially for the larger projects that are going to trigger PR 3 or performance requirement 3, retention and performance requirement 4, peak flow management. This is a screen capture of the City of Monterey's public GIS portal. And it gives you information such as whether or not you're overlying a groundwater basin, et cetera. And so a lot of local agencies may have a mapping portal that you could get this information, but it's also, as Valerie said, available on the regional board's website.
So next I'll look up precipitation. So 85th percentile, 95th percentile, and my 2 and 10-year storm events. And just, I'm not going to read over all the info on the slides. There's a lot of info on our slides. It will be posted later. So I did try and include the links as we go along. Next, I'll look up floodplain. We do not have any floodplain concerns. Looked up drainage. We don't have any drainage channels. Soils and ground in a park on this particular site, unlike the past few slides, we did actually identify the groundwater and any deep stormwater control measures that we might install underground chambers, for example. In my project timeline, at the beginning of the process, I looked up the soil survey information that told me, my saturated hydraulic conductivity of the soil is 6 to 20 inches per hour. About halfway through preliminary design, we actually got the geotechnical report with the infiltration data. That's the table on the left is their summary table from the geotechnical report. They gave me infiltration rates of 84 to 100 or to 216 inches per hour. I ran the Porchet calculation, which is what Valerie went through earlier, and that gave me the field saturated hydraulic conductivities you see on the right, so 1 to 8 inches per hour. You see that's quite a bit different than the percolation rates that the geotechnical report said. Okay, setbacks to structures and slopes. When we were preliminarily laying out the bioretention areas, I did identify one pond would need to be located less than 10 feet away from the proposed building. So I coordinated with the geotechnical engineer. He determined that it would be acceptable to place the pond closer than 10 feet, provided we had mitigation. The mitigation in this case was to provide a liner on the side wall that was closer than 10 feet to the building. So moving on, water wells, also no issues. Easements and utilities. As you see, there are both on-site private and on-site public utilities. The private utilities we're going to remove, so that's not a constraint. There's a sewer line running on the back side of the property on the right side. Do I have like a pointer? Yeah. So this sewer line actually, we'll see later, is a site constraint, as is this one, just because of the setbacks for any infiltration-based SCM. The on-site utilities are going to be removed. Underground hazardous materials, also no issues identified there. So now we can finally start looking at our stormwater control strategy. So this begins with tier 1. Mr. SWIP template is on the left-hand side of the screen. What I ended up writing in my stormwater control plan template is on the right-hand side. So replace the template kind of instruction text with my proposed text. And I'll just mention for those of you that do prepare stormwater control plans, I prepare quite a few of these. In my template, I've actually saved sample text. Some people call this a go-by rather than a template, but that way it's text that I can quickly copy and paste. And I know that I've gotten that through the gauntlet of review on prior projects. So it's kind of, pre-approved in a sense text. I find that very helpful and expeditious. The minimum tier 1 measures, I've just formatting wise put that in a table in my stormwater control plan. So you'll notice in this sample project, I am actually proposing pervious pavement as one of my tier 1 measures. On this particular project, this is not because we need the pervious pavement to meet the area and volume requirements, but because the owner wanted pervious pavement. They wanted the aesthetics, and they just liked the idea of pervious pavement. So that was, in my mind, a perfect situation to use pervious pavement. Tricia, if you wanted to say anything on these, just please hop in.
Sure, I might just say, remind people, as Valerie said, and Nathaniel's talking through here, tier 1 features are super important. They're required on all the PCR projects. A lot of people there are sort of 2 parts to tier 1 or performance requirement 1. A lot of people might think that all they need to do is say, we don't have drainages coming through the site, we've minimized impervious surfaces, but there is this really critical piece where there does need to be a selection of one of these runoff reduction measures. And so that's something that if I don't see something clearly in the stormwater control plan, I will flag that.
Yeah, thank you. Yes, I know I've gotten that plan check comment from you on numerous occasions in the past. So also, maybe before we move on, I will flag that some of these tier 1 measures are absolutely no cost. So impervious area disconnection, downspout disconnection, those are no cost. Pervious pavements, cisterns have a cost, obviously. So when I'm designing a project, if the owner wants a cistern, if the owner wants a pervious pavement, that's one thing. But in general, I go for the free tier 1 measures. So here are some example photos of projects that we've installed over the last probably 5 years locally. These are all pervious pavements. You see they actually are an aesthetic element of the site. Other measures that we did consider for the project, but we marked as not included. We did not do a rainwater cistern. We did not also do other pervious pavement systems. So got pervious concrete on the right. We didn't do rainwater cisterns because the owner in this case did not basically have an interest in rainwater harvesting and reuse. That is a technology or a stormwater control measure to implement only if the owner wants it, right? Because it does require regular usage, operation. The owner has to go out and, if it's a small system, as we've got pictured, the owner has to go out and do stuff with it every time it rains. So if the owner does not have interest, it would not be a good fit. And I'll just flag here. Midway through design, we'll talk about this briefly later. Midway through design, we found out that, in fact, we can't take the roof downspout disconnection credit. So in my preliminary stormwater control plan, I had a yes there, but in the final, I had to actually put no there because of grading complications. So we're finally at what the designers think of as the meat of the stormwater control plan. This is kind of my overarching paradigm. So let's put up the site plan again and go through it. So this is my preliminary stormwater control measure layout. As mentioned, the owner had interest in a decorative pedestrian paving system. So we did decorative pervious pavers. Then I preliminarily sized my stormwater control measures. The bioretention ponds are going to do the heavy lifting in this design. Bioretention ponds are the least expensive on a per square foot of impervious area treated basis stormwater control measure that we have. They're the least expensive up front and least expensive on a long-term maintenance basis. So I love bioretention ponds. So we already discussed PCR1. PCR1 is not required to be numerically sized. PCRs 2, 3, and 4, we are going to meet, like I said, primarily with the ponds. Obviously, the pervious pavers do provide a benefit as well, but the heavy lifting is going to be the bioretention ponds. We also have a pervious geocell fire department driveway on the side. That was also not an initial piece. If you flip back a few slides, you'll notice that that was originally an asphalt driveway, but we ended up switching that part way through because the pond in that back corner ended up getting squeezed along the way. So we ended up removing some of its impervious area to make it fit. Also, the pervious geocell driveway, we were able to landscape, so we didn't have a big driveway around that side of the building. So it was an aesthetic benefit as well. As mentioned, the bioretention ponds are going to do the bulk of the work. Whoever developed the bioretention pond kind of specification that we have right now was a genius. It works really, really well. And like I said, it's inexpensive. The only drawback that I see to bioretention ponds is they do require space. They do require real estate. So we need to plan for them. So, okay, so PCR 1 done. So now we're going to size our ponds to meet PCR 2. So PCR 2 is a simple area ratio typically. The area ratio is the pond bottom. As Valerie said, the pond bottom area ratio to the area of equivalent impervious area. So that's the area of the impervious surfaces with a runoff coefficient of 1 and the pervious surfaces, or the planter areas with a runoff coefficient of 0.1. So determining that area ratio is a 5-minute exercise, goes very quickly. It's a linear activity. We need a minimum of 4% for bioretention, unless you run a volumetric analysis for it. That said, I do not start myself. I do not start with 4%. We will paint ourselves into a corner with 4%. So I start with 6%. 6% for me is kind of the Goldilocks size. At this size, it generally can meet PCRs 2, 3, and 4 without a deep rock section, without a complicated overflow structure. So these are 4 photos of a single bioretention pond at various stages of construction. It was sized around 6%. As a result, it was easy to construct and it didn't have a deep rock section. Also notice in this photo up here, we actually left a 2-foot bench behind the curb, between the curb and the excavation. That provided curb support without having to provide a deepened curb, which also saved quite a bit of money. These are photos of a bioretention planter at a 4% area ratio. While the final product up here looks the same as any other bioretention planter, it did end up requiring a rather deep excavation, and it needed flow control structures in order to meet PCR 4. I'm flagging this early because the decision on the area ratio has a significant effect on your sizing calculations for PCRs 3 and 4, and a significant effect on cost later on. There are a couple of other things, just actually real quick before we move on, I wanted to flag. So my initial concept for a bioretention pond, 6%, plenty of space in this planter. Things start getting squeezed with that bioretention pond. I start looking at other planters. This planter is obviously not going to help me. It's got other stuff going on. I end up with a slope, a 3-to-1 slope down to the pond bottom. I end up with a transformer. I ended up with a joint trench. So this is an exact scenario where we start with the 6%, which is very comfortable, and we're in good shape to still meet our 4% area ratio at the end, right? If we had started it at 4%, we would be very lucky to have 4% at the end, right? You don't want to be pulling your hair out when you find, for example, that there is a PG&E transformer in your pond that you all of a sudden need to reduce your pond to accommodate. So if I start with 6%, I'm very confident I'm going to have the required 4% at the end. Final point before I move on. You'll notice that we've got some rather tall curbing here, some tall light foundations and liner. All that is in part because we only provided the minimum 6 inches of soil bench between the back of curb and the excavation wall. So in hindsight, we could have simplified this whole thing if we had started with a 6% area ratio and then provided or planned on 2 feet between the back of curb and the excavation wall. This rather robust perimeter is because we started at a 4% ratio to the back of curb. Okay.
Nathaniel, may I make one comment here?
Please.
Yes, so one thing that I see folks do often is they might get in a squeeze, kind of like Nathaniel just outlined, where they have these utilities. So they initially submitted the larger facility, then they have the utility situation. They'll do an iterative process sometimes and go back and revisit tier 1 or self-retaining or self-treating areas. Is there anywhere else that maybe we just didn't look at the first time that we could potentially sort of reduce the impervious surface area going to that facility as well? So that's another approach just to reduce the volume. So we see that happen.
Yeah, no, thank you. And that's exactly why we ended up with the fire department, the pervious fire department driveway. Initially, we were going to do that as a asphalt, traditional low-cost asphalt driveway, but we were getting pinched on that northern property line with this pond. We've got other stuff going on over here. So yes, we reduced our load on this pond by reducing this impervious area. So, okay, so I'm happy with my site plan at this point. The last thing I'll mention about the site plan, though, is roof drainage. So as mentioned before, bioretention, as well as other SEM types, really prefers to receive surface drainage. As soon as you put water into a pipe, to get that pipe to daylight into the pond, that pond is going to need to be about 2 feet deep or more. So unfortunately, our building has downspouts at the rear of the building. This is typical. It is problematic in this case because we can't get those downspouts to splash to grade and then get a flow line graded all the way to our ponds. Also, there's a sewer main, if you remember, along the back of our property. So we cannot put a pond immediately behind the building. So that means we have to pipe the water into the ponds. So now all of a sudden, these 2 ponds adjacent to the building are not 6 inches deep, they're 2 feet deep just to receive those pipes. This is totally acceptable from the PCR standpoint. It's totally acceptable from a design standpoint, functionality, but it does have a couple of drawbacks. One, a bioretention pond that receives just surface drainage is 6 inches deep or a little bit more, so you got some freeboard. So you can use your whole planter, right? This is the one that I had with the 2-foot shoulder to the back of curb. This is a bioretention pond that's 2 feet deep. And so my actual pond area that I can take credit for is much smaller inside my planter. So a deeper pond takes much more space for the amount of pond that you get credit for. The second thing that I'll mention, and this may be a personal preference, I like the way bioretention ponds look when they're shallow. I think they're very aesthetically pleasing. Once you start getting to deeper ponds, this is a 2 to 3 foot deep pond, I find them, they look more like a pond. I find them to be less aesthetically pleasing. Also, the side slopes do suffer a little bit more from erosion, right? This guy has no erosion problems on his side slopes. Okay. So that was PCR 2. I sized my ponds. They're between 4 and 6%, and I'm happy with that. So now I run my PCR3 calculations. So this is the calculator that Valerie mentioned. The calculator, you put in the pond areas, put in your tributary areas, and it calculates your depth and your volume. And so the calculator either gets copied and pasted into the stormwater control plan or into an appendix of the stormwater control plan. And then this is my summary table that goes into the stormwater control plan. So that's the retention volume below the perforated pipe. Again, shout out to Dan Cloak for putting this calculator together. It is great, and I love it. So PCR3, I did forget to mention. So the output of this exercise was we're proposing 2 feet of drain rock. Calculates, looks like about 1.5 feet. So PCR3 is done. Now we run the volumetric analysis. So the inputs that you need for the volumetric analysis, some of them you will find in, I forget what this is, table 1 in the PCRs. You need all of your drainage management areas. You need your stage storage discharge table. For your pond, for this, you need a pond design. And then you can set up your model. This is for PCR4. We'll also be addressing any additional flood control calculations that are required by the local agency. On this project, as I mentioned, City of Monterey doesn't require anything additional for flood control, additional to what's in the PCRs. So you have to use a computer program to run these calcs. So that's going to be HEC HMS, which is what I printed on the screen here. You can also use something like HydroCAD. Sometimes the local agency requires these at planning. Sometimes they don't. I tend to run them at planning, even if they aren't required. The reason for that is that way I know if after I've sized my ponds for PCRs 2 and 3, if I need to upsize the ponds to meet PCR 4, or if I need to include any, for example, any underground, additional underground storage to meet PCR 4. That's not going to be a problem on this project because it's a redevelopment project, but it can be an issue on greenfield development projects. Unfortunately, as you see here, the calculations require a design to start. So these are guess and check calculations. Some of the rules of thumb that I use just to get a preliminary design to start running the calculations. Again, we're looking at a redevelopment project. So again, I'm going to shoot for a 6% area ratio for my ponds. I'm going to run it through the Central Coast calculator spreadsheet. That's going to give me my rock depth. The rock depth is not very great because we do get that 50% credit for all the replaced areas. At this point, I'm going to run the calculations through HEC HMS for PCR 4. This is a redevelopment project, so I'm very confident that the pond design that we already have is going to just work, right? Because we for PCR 4, we get a credit for all that existing impervious area. If it were a greenfield development project, there's some other kind of rules of thumb, again, just to have something to start running the calcs with. But for a redevelopment project, the standard pond typically works. We don't even have to have float control orifices a lot of times. So this is what we get out of that model. On the left is a screenshot showing the 10-year analysis run. I put this screenshot along with the rest of the screenshots from the results in an appendix in my stormwater control plan. On the right is the table that goes into the body of the stormwater control plan. So and I'll just mention in this table, in this example, you see the 2 through 100 year, the PCRs require the 2 and 10 year. The 2 through 100 year required by some jurisdictions. For example, this was for Monterey County. So this combines PCR 4 and the county's drainage requirements. So a couple of just real quick tips on checking these. First, check that The pre-development and the post-development site areas are identical. We need to be comparing apples to apples. So those two areas need to be identical. Next, I prefer, and this is my preference, to size my outlet structures and my storm drain pipes, basically all the gray infrastructure, without accounting for my detention volume. So if you look in here, we've got 3.9 plus 0.1, 4 CFS coming into SCM1 and 2.4 CFS coming out, right? So we're modulating the flow coming in and getting about half that flow out. If I can, where I can, I actually will just size my storm drain to handle the 4 CFS. That way, if something happens, if the pond is already full from a previous storm, when a big storm comes in, I'm not relying on pond volume. So it's a, you might call it a belt and suspenders approach. Again, this is not for a municipal storm drain system serving an entire city. This is just a small on-site system. So we're talking, 8-inch pipes, 6-inch pipes. So this was PCR 4 and local agency drainage requirements. So finally, I'm going to check emergency overflow paths. So agency requirements vary on this analysis. I think of it in these terms. The design storm is the storm which we analyzed numerically in the previous slide and size our pipes for, our catch basins, our ponds. What we're looking at here is the emergency overflow path. This could be called a pre-mortem, if you're familiar with Gary Klein. For the types of project that I work on, this isn't necessarily a numerical exercise. The primary thing I want to confirm is that if the storm drain system has become clogged, if there, whatever has happened, no maintenance has happened, that there is an acceptable overland release path. And in no possible scenario do we have the building flooded, or if we cause flooding on an adjacent building. So my analysis for this one was as simple as I looked at the grading plan, pretended all my storm drains were clogged or who knows what, and we've got overland release, in this case actually through the frontage, which is preferable. Let's see. So the calcs are done. We can focus on the construction documents. The construction documents need to contain all of the detailed information that the contractor needs to know to build the facilities. Remember your audience when preparing your plans and specifications. Construction workers, they do not have an engineering degree, so they like things to be well spelled out and clear on the plans. Also remember, the construction contractor does not see the stormwater control plan. That's a permitting document. The contractor only sees the plans and specifications. So here's some example details and notes that I've been including lately. I include all of these on my plans. So not just the detail, but I do like to talk about local agency inspections, because those are different than the CBC required inspections. These are specific to the stormwater control facilities. And then I will actually copy the stage storage table from the stormwater control plan onto the plans to make sure that they're both consistent. These are some example sheet specs. A couple of things I recommend including construction observations. That's the engineer of records observations. We do not want to be at the end of a job and find out that the contractor has installed, the rock and the BSM and not call us out to do our observations. So I include my observations, and then I do address as well as I can scheduling and pollution prevention. This is huge. We need to protect stormwater control facilities from contamination during construction. So we need to tell the contractor what we expect of him. So again, as mentioned earlier, these are specific notes from a very specific job and a very specific jurisdiction with a specific timeline, not applicable to all scenarios and situations. So also, I'll just mention water does run downhill. So, I've seen plan notes say, no construction water shall enter the bioretention pond. In general, that doesn't work because the bioretention pond is at the downstream end of the watershed generally. And so it will receive water when it rains from the construction, from its drainage area. So we need to give the contractor specific and implementable instructions on what he's going to do to keep that pond from getting sedimented or otherwise damaged when it does rain. So we shouldn't give them vague and not really implementable direction. It's not helpful. If we cannot articulate to the contractor what we want him to do specifically, he's also not going to know what we want him to do. Example specification page, if there are book specs, some more supporting details. These are from the Low Impact Design Initiative. So now we are at the end of the design phase and into construction. So these are the primary points I'm going to discuss. The review of submittals and inspections and observations are how we confirm, as the engineer of record and the local municipality, how we confirm that the project is built in conformance with the plans and specs. So we use these as the basis of our certification of the completed project. The observations that I perform for bioretention ponds include the pond excavation, drain rock, pipes, and structures. This typically requires 2 visits, so one for the completed excavation, and then typically the second for the rock and pipes and structures. Then I observe final grading and landscaping. So we see on the final graded pond, final landscape pond. On the one hand, there isn't a need for a separate final grading and separate landscaping review, but I've personally found it helpful to have both of them so that if we do see any issues with the grading, we can have them corrected before they start installing irrigation and landscaping, because obviously that's a much bigger headache for the contractor if they've got irrigation installed and then need to regrade. Also, I'll just point out in this example, we put the bioretention soil on the shoulders here, so 6 inches on top of the native soil. I think that actually really worked well. It kept the native clay soil from just creating nuisance erosion into the pond during construction. And it also allowed us to do a very small amount of fine grading just within that VSM layer. So similarly, we performed observations for the other stormwater control measures on the site. At the end of construction, we complete the engineer's stormwater control measure certification. The municipality may also have certifications that they need to complete. If there is a SWIP, the QSP will also need to certify that the project has been completed. These are the City of Salinas forms. Just as one example, not every local agency has forms. So if a local agency doesn't have language, I typically use the City of Salinas as a kind of a baseline to copy from. So now we're all done with the project. Just kidding. We totally forgot about the maintenance agreement again.
Yes, and Nathaniel, did you want me to? So from the local agency process standpoint, we're not quite done. We do need to work on executing a maintenance agreement with the property owner prior to the final occupancy for the project. And so we have 3 important exhibits that are attached to that maintenance agreement. But what I'll do is just point out what I feel is the most important one, which is Exhibit C for us. It's the O&M plan. And that the O&M plan contents, as Valerie had noted, have particular items that need to be included in them, but that document is a standalone document for the owner. So that's the current owner and any future owner. So I just want to point out how important getting that O&M plan to be accurate and fully detailed so that any future owners can understand the needs for those technical stormwater facilities into the future.
Cool. Yeah, and I will just highlight, don't wait until the owner calls you at the end of construction because he needs his occupancy and he's waiting on getting this done. That's typically the way it goes. That we do not like being in that situation. So get this submitted early in construction so that we're not waiting on it at the end of construction. Depending on the agency process, it can take 1 to 2 months to get this through legal review and recorded on title.
Yeah, and there may be certificates of insurance and those types of things. So things can take time, and then the processing with risk and legal and all of that. So,
Yep, exactly. Thank you. So just splashing up on the screen, that's a example. Forget if that's City of Monterey.
City of Monterey, yep,
okay.
that's the City of Monterey template.
Yep, so that's your O&M agreement template. These are kind of my internal templates for exhibits A, B, and C. Exhibit A, legal description. That's the legal description for the overall parcel that the agreement is pertinent to. So it's not a separate legal agreement for the stormwater control measures. As Valerie mentioned, exhibit B, formatted black and white. You can expect the scan to come back to you after it's recorded rather poorly. So don't use exquisitely small fonts. Don't use gray hatches, black and white, minimal content. And I think I heard, Jeff, that you guys approved the O&M fact sheets yesterday. So those are going to get posted to the website. So that's a huge help. So we've got those to start with. Did you want to?
Yeah, so just from the agency standpoint related to when we get to this point of construction, communicate with the agency inspector on what that schedule is for the SCM or PCR features construction. And really those features will be inspected by the design engineer, hopefully, but also by the local agency over the course of that features construction at the intervals that Nathaniel had described. We do recommend that the design engineer is on site for those agency inspections. So if there are any questions, they can answer questions. And then the PCR, the certificate at the end is a helpful record related to ensuring that those features have been constructed in conformance with the PCRs. And then, as we've already stated, in advance of the final certificate of occupancy, coordinate, communicate, make sure you get that maintenance agreement executed. And then we actually, at our agency, record the document over at the county on the deed. And like I said earlier, the exhibits to the maintenance agreement are key. They need to serve the long-term in perpetuity of that built project for every owner along the way. So really critical that the O&M plan is accurate and clear.
Cool. Yeah, and I'll just say, again, just to reinforce, we really need to protect during construction, protect our stormwater control measures. So I've been talking a lot about the ponds. A lot of this will apply also to pervious pavements, to underground chambers, to any facility that's going to be infiltrating stormwater. We really need to protect it from getting construction sediment into it and clogging up the pores and reducing the infiltration rate. So scheduling is our most important BMP in that regard. Also, I'll just say that water is irresponsible in where it goes. We might think that we draw a line and say that's a fiber roll, but water is going to do what it does. And so plan on that. Don't draw a line on a plan and think that the water is going to know your intent. Also, go for it.
Oh, sorry, go ahead.
Oh, so also the other most important thing that I'll say is don't leave the rock reservoirs exposed. If we do get construction sediment washed into an excavation, we can strip out a very small amount of soil and move on. If we get it into the top of the BSM, strip out very top inch or two of BSM, move on. If we get that sediment into the rock, we're taking out quite a bit of rock because the sediment can penetrate into the rock reservoir. So we really need to protect the rock reservoirs from getting sediment. It's a lot more work to deal with. And then remember, for the engineers on the call, you will have to certify that the work was completed in accordance with the plans, specs, and stormwater control plan. Did you have anything before we went on?
Yes, my apologies earlier.
Yeah, go for it.
I was just going to note, I just want to speak to the fact that it's really critical and important that the designer ensures that that final design package, and when I'm talking about package, I mean the final stormwater control plan, the final plans or drawings, and including the details, are all internally consistent. And, you know, we look at that when the document package comes into our building office for review, but that's something just that we can kind of kick it back to you and say, things aren't matching up between the documents. And this goes to what Nathaniel is saying about the folks out in the field need to have accurate information, especially on the plans and between the plans and the details. And so just making sure that consistency there and all those three documents are internally consistent, I call it, is a really critical step for you. So then when we receive the package to review, we see that the whole story, you're telling the same story in each document. Nothing's diverging from the original story.
Yes, yeah, and that I will say from my point of view is that takes a lot of work to make sure everything is consistent because there's a lot of documentation. Yes. Okay, so we're now here. We're done with construction and finally the O&M plan. So we're now in the project utilization phase. So the permit does require maintenance be performed. The specifics of that's actually in our O&M plan. So all of this work is per the O&M plan. So there's, I guess the way I think of it is there's regular maintenance that the owner completes or maybe his landscape contractor completes. Some stormwater control measures require specialty work. So underground chambers, underground filters, you know, those require them to contract a Vector truck. Tree box biofilters, typically there's a contracted maintenance with the manufacturer. Pervious pavements similarly. I would just flag that there is a cost difference to the long-term operation and maintenance of the stormwater control measures that you choose. Some have much higher long-term costs than others. Again, I'm a big fan of the bioretention pond, simplest thing there is out there. Also, some jurisdictions require the annual SCM inspection specifically to be completed by a professional engineer. I think locally that's just Seaside and Monterey County, but that's something that will be in the template. So just keep your eye on that. Here's an example annual maintenance certificate for City of Seaside. Some photos of me doing some annual inspections of various facilities. Tricia, do you want to?
Yes, great, thank you. So at this long-term in perpetuity of the built project or the utilization phase that we call it, what I found is the first few years, it's a bit of a learning curve for the owner. So their team, their project team may be very familiar with all these facilities, but it is typically, there's a bit of a learning curve. And so I have found that there is some guidance required at times. And then those records that both are given to the owner and that are maintained by the agency are critically important, because not only do they allow the current owner to understand what needs to get done on what frequencies and how, but it also informs any future owners as well as any future development on that same site to understand if, oh gosh, you know, this future redevelopment that we're going to do on the same large parcel, we're actually going to encroach into one of these bioretention facilities. So we need to rethink the bigger plan in the next project. So really critical to have those records.
Yeah. And I'll just, I guess these are encouragements to the designers in the room. Take time for lessons learned. You know, unfortunately, that's kind of a piece that can get left out in the hustle bustle every day. But the lessons learned are important. They inform our future projects, so there are, the mistakes that we made don't get made the next project. Also, encourage you to touch base with the project owner maybe a year after construction. Ask them how it's been going. What's the good and the bad and the ugly of these stormwater control features. Typically, we don't get that feedback unless we ask or unless something significant happens and they call us, right? But we do want to get that feedback. All those maintenance considerations should inform our future designs. Also, if at the end of construction you haven't been contracted to do the annual inspection and certification, check in with them when it's getting close to the annual inspection time. Not because you want the business, but just to make sure that they haven't forgotten, because this is the first year they're gonna have to do it. And they were probably so happy to be done with their project, they filed it all away and it's nowhere on their radar. So check in with them, say, hey, you got your annual inspection coming up. You got someone handling that? Are you doing that? Do you need a PE to do that? Just make sure that that's going to get done. Otherwise, Tricia will call me and say, hey, so-and-so is not giving me their report. Have you contacted them already? So similar to Valerie's slides, we have some slides here at the end of just some web links. These are actually just some screenshots from the Mr. Swimp website. These are some other links to some other really good stormwater control measure details, computer programs that we've talked about. And I think, Jeff, we'll turn it back over to you. I think we're at the Q&A part.
Yes, fantastic. Thank you both. That was really, really helpful. Nathaniel, I'm going to ask you to quit sharing your screen if that's possible.
Yes.
Okay. I'll share my screen. All right, we have come upon the question and answer portion of our presentation, our training today. So I've been keeping track. Thank you all for the attendees for submitting your questions throughout today's training. I'm going to just go through some of the ones that came in, and we'll try to get through as many as we can today. I'll kind of go back and forth, ones that were addressed to Valerie's presentation, and then those that were addressed to Tricia and Nathaniel's presentation. So Valerie, a quick question that came up for you was, how are curb extension projects treated, or bike projects that modify the right-of-way? Aren't these exempt under the state and Central Coast PCRs?
There are specific exemptions for pathways like bike path or pedestrian path and even sidewalk projects if they are draining to a pervious surface. So that is a specific exemption that's in the PCRs itself. Again, if you think you fall under that exemption, read the text of the PCRs. But in general, if you're draining to a pervious surface and it's a new path, new sidewalk, then you are exempt.
Great. Okay, thank you. And then another question that came up during your presentation was, one single family home? If there's a single family home with an ADU or perhaps an accessory structure like a barn, does that project fall into everything else?
That project would typically still fall under the single family home. And I know specifically here in SLO County, our county has just released a draft guidance manual that very specifically states that an ADU on an existing single family parcel is still considered a single family home. So in general, ADUs will be permitted in the same fashion as a single family home, and they still fall under that single family category for PCR compliance. Again, check with your local jurisdiction, because if you're talking about building multiple single family homes under one building permit, then you may need to fall under that everything else category.
Okay, thank you. Checking in with your local jurisdiction seems to be a theme, recurrent.
Yes.
Can you, and then another one for you, Valerie, and then I'll bring some for Nathaniel and Tricia. Can you comment on why the design storm is required to be a 24-hour duration, please?
Sure. So the PCRs specify a 24-hour duration because we're looking at a volume basis. So we're looking at the total volume of rainfall that occurs over that 24 hours. Sometimes for flood control, we may be looking at a shorter duration storm because of intensity, but the PCRs are volume based. And so therefore we want to capture that full 24-hour volume.
Okay. And then this was a more of a kind of a technical question that came up for your presentation, Nathaniel and Tricia. For infiltration rates AB or CD, do you have size requirements that we should list in bid documents?
Sorry, can you repeat that?
Sure. For infiltration rates AB or CD, do you have size requirements that we should list in bid documents?
Sounds like a hydrologic soil group.
Yeah,
Yes.
I guess I'm not understanding the size requirements. So I guess the way I normally format it is we do the infiltration testing as early in design as the owner is willing to pay for it. So hopefully during the planning stage, because it can significantly affect the design of our stormwater control facilities. So we get that done during design. We size the facilities. What we give the contractor is really not dependent on the infiltration rate. So he doesn't, that's not something kind of that's on his radar to double check, if that makes sense.
Mm-hmm.
So yeah, so the infiltration rates are really, really important to the design of all of our stormwater control facilities. So we do need to get that really early in the game.
Great, thank you. And then another question that came up for you, Nathaniel and Tricia, sieve size for gravel inside the bioswale, question mark?
Yes, I think the short answer is there are various details and various specifications. City of Salinas has published details, Low Impact Development Institute or initiative. They've got some details that the Mr. Swimp group has links to on its website. I don't think they're, I guess, adopted per se by the local agencies, but and then Caltrans has specs. They're all very similar, but different. And so I'd say, the designer of record will propose something and the jurisdiction will review it.
Okay.
I think asthma also.
Yeah.
Has
And so we tend to use for the reservoir course, we tend to use like a 3/4 inch or a 3/4 to 1.5 inch because it has a good void ratio, right? It's got a 0.35 void ratio. And then we'll have a filter course on top of that, right, between the BSM and the reservoir course. And so the filter course, some people use class 2 permeable, some people use a smaller uniform graded, for example, pea gravel. I've seen both used. I would not use class 2 perm for the reservoir because class 2 perm actually has a fairly small void ratio because it's a mixture of gravel and sand.
I see. Great. Okay, that's really helpful. And then Valerie, this is going back to you. We're looking at the calculator. Is the Excel sheet using Q CFS equals CIA? A little technical.
Yeah, so that question is asking if the Excel sheet is using the rational method, and the Excel sheet is using a hydrograph runoff method, specifically the SBUH runoff method. So that's it's a common method that's applied for urban areas, and the Excel sheet in the background tabs is running the full 24-hour hydrograph using that particular SBUH method.
Yeah, and I think the SBUH is identical to the runoff curve number method, if I'm remembering.
It is nearly identical. One of the most important differentials is that the SBUH method calculates the runoff from pervious and impervious surfaces separately. So the standard NRCS TR55 method will take a composite CN value, which will tend to underestimate runoff from your impervious surfaces. So the SBUH is preferred in the urban areas because of that ability to calculate the runoff from impervious separately, and it gives you a slightly more realistic value.
I gotcha.
Okay,
And it does use the same CN values as an input.
okay. And this was a follow-up question. You may have just answered this, but the Excel sheet says rain intensity I value of 1.1. Can you clarify where that number came from?
I'm not sure where that would be seen on the spreadsheet. I don't recall seeing 1.1 on the spreadsheet. Typically, the only time that intensity is used for a PCR calculation is if you're doing a flow-through facility for the 85th percentile storm. And that standard rate is 0.2 inches per hour, and that is listed directly in the PCRs.
Okay,
If they were, so we put up a couple of or one of the calculator screenshots as well. If they're referring to that screenshot, that would probably be the 95th percentile 24-hour storm depth. 1.1 sounds like it might have been that storm depth.
okay,
Yeah, so all of these volumetric calculations, as Valerie said, are based on the 24-hour storm. So yeah, the intensity-based calculations or the rational method calculations are only for pipe sizing, catch basin sizing, kind of instantaneous flow calculations.
great, great. And then this one is just for any of you or all of you. The PCRs are a bit weird in that a surface is either pervious or impervious. For example, a field where the soil is heavy clay is pervious despite low infiltration rates, but a gravel driveway is impervious, ? Is there a more objective way to classify pervious or impervious?
I'll take a stab at it, and Tricia might shoot me down on it. The Santa Barbara urban SBUH model, the spreadsheet, or the runoff curve number method, same model. The curve numbers do account for the soil type. So if we were in the middle of Salinas, we've got fat clays, that curve number from that agricultural field might be 88, which will model and produce almost as much runoff as a parking lot, right, in a large storm, like in a 100-year storm or a 10-year storm. But so that's a numerical analysis, numerical difference, but that's not the same question of what's considered pervious or impervious for determination of what PCRs is our project subject to. So that's they just have a clean break, pervious and impervious. If it's a concrete or asphalt, or in many cases DG even, or gravel, that's impervious. We count it as impervious. I have in the past for gravel driveways called those semi-pervious, and then because it will have a different runoff curve number, but then for determination of which PCRs apply, for determination of PCR2 requirements, those semi-pervious kind of gravel driveway areas, I will count those as impervious, and they'll have impervious runoff coefficients. That may be too much information.
The EISA calculation also does look at what are considered pervious areas, and you apply a cover factor, so it may come into play there. But you're right. I think the regulations are pretty clear that if there's like a natural area that's vegetated, that's going to fall into that pervious, even though it may be have high runoff likely.
Yeah.
Okay.
So it's kind of the permit threshold is not the same as kind of the curve number analysis, the numeric threshold.
Great. Okay, thank you. This one's from our good friend and colleague, Kathleen Garnan from County of Santa Barbara. In underground SCMs, can infiltration be included in the model for meeting PR4, peak runoff control? Or do you assume that during the 2 through 10-year storms, that soils will be saturated and no infiltration occurring, AKA exfiltration? How about the void space? Can they reduce volume by the gravel void space? Or again, assume it's already full and use overflow at outflow invert? And that was for you and Nathaniel and Tricia, I believe.
Gosh.
Yeah, those are very good design. Those are very good design questions. So I think If you remember, I talked very briefly about, the fact that a bioretention pond will detain, it'll modulate flows. But just what I do is I'll, if I can, size my storm drain just to ignore the pond, assume the pond is full. That's a belt and suspenders approach. And so I think implicit in that question is, what do you think about taking a belt and suspenders approach to an underground system that maybe has other physical things going on? Maybe it's got, already a bunch of saturated soil around it. That's a design engineer question, and then it will be a reviewer question as well. And very project specific.
Okay. And then another question that came in, is there a max infiltration rate we should allow for bioretention? Sometimes bioretention is limited by the infiltration rate of the BSM and not the underlying soil, right?
Yeah.
Yes.
If you or Valerie wish to answer or speak to that as designers.
I'm happy to, but I've been talking a lot, so
Yeah, I'm happy to answer that. Typically for bioretention, the design infiltration rate for the media itself is 5 inches per hour. And that's just the rate that the media has been tested to show that it's actually providing treatment. And that's where that 4% rule comes from. So the 4% rule is based on a 5 inch per hour infiltration rate into the media. And so long as you're meeting your 4% rule, I don't see that you would really need to specifically account for that separately from your sizing calculation. I would say probably the only time you're going to exceed 5 inches per hour is if you're building in a really clean sand.
Mm-hmm. Yeah. So so we do actually have that in the Monterey area. So city of Marina, city of Seaside, are ancient sand dune deposits. And so yeah, so we do frequently get infiltration testing even after we run it through the Porcher method. That gives us really, really high perk rates, north of 10 inches an hour. So personally, I tend to cap the infiltration rate at 5 inches an hour precisely because that's what the BSM is doing. So if the if the runoff coming into the pond can get through the BSM, it's just going to keep on going, right? It is what the model would show. Also, because if you do have, if you've got a pond that you've got a drain rock reservoir under it, and maybe you've got some chambers under it, you will tend to get some fines collecting on the bottom of the drain rock reservoir, right at the soil interface, and that can really significantly reduce your infiltration rate. So, if you're counting on 20 inches an hour, that soil interface needs to make 20 inches an hour. So if you back that off to some rate that you as a professional engineer have determined is an appropriate level, that just gives you added safety factor. And I will note at high infiltration rates, so like over an inch an hour, the drain rock reservoir course is very sensitive to the soil, the native soil infiltration rate. So if you plug in 20 inches an hour, because that's what the geotype report says, versus 5, that will have a really substantive effect on how much drain rock you have to provide to meet PCRs 3 and 4.
Okay. The next one that came up was, what is the general guidance for bioretention areas, stormwater features, setback distances from neighboring buildings or neighboring property lines?
So I would say it's the same as setbacks to on-site facilities. So we provide 20, for example, for a building, preferentially 20 feet setback. If we're less than 20, we start talking to the geotech. Generally, frequently, they're okay with 10 feet. And then less than 10 feet, we have mitigation. So we generally want to implement. So the same would apply for a new building on our site as to a building on an adjacent site. If there's no building on the adjacent site, there is the question of, do we design to an assumed building that might be put at the yard setback on that adjacent site. That would be very prudent.
Okay, okay.
And
And then, I'm sorry,
Jeff,
go ahead.
yeah, I just want to add to that. There are generally other setbacks that are identified in the technical guidance manuals, setback for things like wells, setback for slopes. And so you need to also look beyond just the next property line to see if these other type of features exist, because that setback may dictate a greater setback than just, 10 or 20 feet from the property line.
I see. Okay, thank you. Can somebody talk about using tree pods, quote unquote, and filtration vaults in lieu of bioplanters?
Like biofilter, tree box filters
I
in
think
lieu
tree
of
box
biofiltration.
Yeah, I think they mentioned tree box filters too.
I think Nathaniel does.
I actually do a fair amount of these, but if anybody else wants to take it, I'm happy to. Okay, so I do a lot of my work in Monterey. This is a rather densely developed area, and a lot of my projects are redevelopment projects, which means even more densely developed, right? So we end up using tree box filters quite a bit. So if we're in PCR 4, not PCR 4, watershed management zone 4, there are no detention and there are no retention requirements. So if we're doing our initial stormwater control plan layouts, the PCRs, are very, very clear. You do your tier 1 measures, you do your tier 2, within tier 2, they want you to do bioretention. If that's not feasible, you do biofiltration. If that's not feasible, you can do a non-LID system, which is a tree box filter. So you do have to demonstrate that those are not, able to be accomplished, due to site constraints or, generally it's site constraints. But we do a fair amount of tree boxes. I actually really like them. If you just have PCR 2 that you need to meet, they're actually comparable cost to a bioretention pond on a per square foot of treatment area basis. And not in a long-term sense, not a lot more cost for O&M, because similar to bioretention pond, it's a lot of landscape maintenance as opposed to getting a Vector truck and doing an underground system maintenance. If you have retention requirements or detention requirements, that tree box does not meet those. So you'd be doing that in conjunction with another system.
Okay, the next one is watershed management zones. Seems project requirements are determined by their location within the WMZ. Where are these requirements found for each WMZ? In which document? Thank you.
Yeah, those are found in the post-construction performance requirement sections. So if you go to PR3 runoff or retention, or PR4 performance requirement 4, the peak flow management, there are specific provisions for various WMZs. So they may have you meet the 85th or the 95th percentile storm event, or they may or may not have you do peak flow management on a site. So it's actually in the body of the actual regulations themselves. I hope I answered that right, Nathaniel or Valerie. Does that sound okay?
Yeah, and I'll say so. The watershed management zones, like the maps, you can get those from the Mr. Swimp website, from the Central Coast Regional Board website. Also, the local agency GIS generally has these as well. So I know City of Monterey GIS, you go there, it's got the watershed management zone map. You go to the Monterey County GIS, they've got the watershed management zone map. And then I think on the Mr. Swimp website, on the first page for the PCRs, you've got a really nice table describing both how the area and the watershed management zone feeds into the post-construction requirements. Because, like Tricia said, it's not just the size of the project. Certain watershed management zones don't require PCR 3, regardless of the size of the project, for example.
Okay, great. I think this one's for Valerie. If using open graded aggregate for gravel or base road, does the road meet all weather access requirements for fire?
I will say I have seen them approved by CAL FIRE, and again, I'll say again, you know, check. This one, each proposed roadway will need to be reviewed and approved by CAL FIRE. As these roadways potentially become more common in our area, because we're trying to purposely design for a pervious gravel road, there may be some newer standards that come out from CAL FIRE that, you know, will blanket and adopt these surfaces. But I will say that I have seen them approved by CAL FIRE. As an example, a typical open graded aggregate would be the Caltrans Class 2 permeable. And that really the surface course is not that much different from a Class 2. It just doesn't have the same level of fines. It's designed to be compacted, so you can compact it and still have a high enough pore volume that you're allowing for infiltration, but you still have a stable driving surface. So, you know, certainly up to approval by CAL FIRE, but the answer in general is yes.
Great, great. And then shout out to City of Santa Cruz. When calculating on-site impervious areas, do proposed pervious pavers areas equal net zero increase to the added created impervious surface area for the project? Do you want me to repeat that? I said it kind of fast.
Yeah, if you could.
Okay. When calculating on-site impervious areas, do proposed pervious paver areas equal a net zero increase to the added / created impervious surface area for the project?
Yeah, well, that would be a tier 1 measure. And so depending how it's constructed, it might be self-treating, just dealing with whatever's raining on itself there. And so the retention requirements you can turn a blind eye to pervious surfaces when you're focusing on the impervious surface totals. So I don't know if I hit that right, but Nathaniel, Valerie, please feel free.
Yeah, I think I'll just add that when you're calculating your new and replaced for the purpose of thresholds, a pervious pavement does not count towards a new and replaced impervious surface.
And I think some of the confusion that I've seen is because there is that EISA table that has a runoff coefficient that you have to apply to pervious pavements. And I'll just say that, so those runoff coefficients in that EISA table is very specific to calculating, I'm blanking on it, Valerie, what's the term? It's your
That table is only for technical infeasibility.
Thank you.
So the only time you would use the table with the coefficients, and there's a relatively large coefficient for pervious pavement, which I don't fully understand. I think it's 0.6. The only time you would use that is if you're calculating your your equivalent impervious surface area for technical infeasibility. Right. Otherwise, for the purpose of thresholds, any pervious pavement does not count towards you, the threshold.
And I would say, so on the design side, we've had this conversation about, you know, at what point does a pavement become a pervious pavement? What I've been told is, you know, so there's the pervious paver, and then there's the pervious, you know, bedding and pervious base and pervious reservoir courses, you know, so you've got a pervious rock course under the pervious pavers. So you can't put pervious pavers on Class 2 ag base and call the system pervious. That is not a pervious system. We see that, you know, people propose that sometimes because it's a lot less expensive. But it's a pervious pavement with a pervious base, and that pervious pavement and pervious base system is orders of magnitude more pervious than the soil that it's sitting on. Right, so pervious concrete, pervious paver system, generally those are on the order of 100 inches an hour infiltration. So they're a pervious system, but we do need to design them as such. So Valerie had some really good slides up about check dams, because we don't, besides the volumetric sizing, we also don't want to create a situation where we've got water running on subgrade down a slope and causing erosion issues inside the base rock.
Okay, great. And then Tricia, this might be for you, though others can chime in. If an agency does not have the software familiarity, is there any available helpful guides to interpret Civil Storm, HydroCAD, or other software applications output data, sizing results when reviewing a project's PR4 compliance?
Gosh, that'd be a great question for our civil team that actually does those checks. But I do know, I believe all the HEC products, I believe, have a user's manual. So like the HEC HMS. But, you know, that's a good question. I'm sorry, I'm not able to answer that. Valerie or Nathaniel, did you want to weigh in on any recommendations?
I mean, I'm on the opposite side of the counter, so hard for me to respond. So I did give some rules of thumb that I use. They're very area ratio based, but I use those just internally reviewing our plans, because sometimes frankly, you plug stuff in the computer and it spits something out and it seems reasonable, and you don't realize you messed up two numbers, or you forgot to add in this little area that whatever. So at the end, I'll do a back check my area ratios, see that everything's balanced, see that the area ratios and the volumes make sense relative to each other. The reviewer can do that easily, right? They can, just divide some numbers that are given in the stormwater control plan. Occasionally, the reviewer will ask for our HEC HMS model. If they were savvy with the program to review it. Personally, if the reviewer has questions or thinks something is looking funny, I do not mind a call. It's a lot easier to get a call and say, hey, I totally don't understand this model.
Yeah.
Walk me through it. I would much rather get a call, talk her through it, him or her through it, than have to explain it all in text in the stormwater control plan, right?
Yeah, or comments back from the agency, right?
Yeah.
We do that a lot with Nathaniel's exactly right. Our civil engineers will do that. They will just call, have a detailed discussion about the particular item. They may not understand what was attached to the back. Why did this number come out in your model? Yeah, I unfortunately don't run those models. We have a different team that does that.
Fortunately, Tricia, you fortunately don't run those models.
Fortunately, I love that stuff though.
And then Troy, I think you mentioned, I can't attest to this, but HydroCAD offers a free version that is appropriate for use and review. Building familiarity is another issue. Okay, can any guidance be provided for the following? Prior to underground chambers, what pre-treatment is required? Swale widths, swale types?
I will speak briefly to this, in that in general, as a designer, if I'm designing an underground chamber, I want to pre-treat the storm that I'm retaining. So the minimum requirement would be treating the 85th percentile storm, and that's really up to the designer to decide, based on your inflow, how long does if you're using a swale, how long does your swale need to be? Or you could use bio-infiltration, and then you could use the 4% rule with an under drain that drains to your chambers. But my rule of thumb is to treat the storm that you're retaining, which is in some cases the 95th percentile, and that's maybe another belt and suspenders approach. But if I'm designing an underground chamber, I don't want it to fail because of sediment, and therefore I want to remove sediment from that design storm.
Okay, great. We are 1 minute left. I want to respect everyone's time. Would you count the side slope as part of the bioretention area square footage, the 4 to 6%, or you only get credits for the area of the bottom of your bioretention area? I believe that was for you, Nathaniel.
Oh, yeah. What I've been told is the bottom only. So that's what we designed to. So if you look at the details that I've had on the plans, my bioretention excavation is identical with the pond bottom contour. So I don't run the bioretention up the sides at all. That's wasted space because I don't get credit for it by sizing. That's a very conservative approach. right? Because we know we've got 6 inches of ponding and the pond gets larger as it goes up that 3-to-1 slope. So it is a conservative approach. It gets me through the process. I don't need to worry about it. So I'm very happy to use the pond bottom.
Great. Okay, and then that I believe takes us to, I'm gonna stop sharing and I'm gonna share again. Oops, sorry. We have made our time limit, so thank everyone for their participation today. We really appreciate it. Hopefully this was beneficial. Please reach out to your local jurisdiction, whenever feasible. I did want to mention that the Mr. Swim program, excuse me, we'll be hosting an operations and maintenance training on how to maintain bioretention facilities on Thursday, May 18th. So this is geared more toward public works maintenance staff and landscaping contractors. So I'll be sending this out through APWA and other groups, but please keep your eyes out for those trainings. Feel free to shoot me an email if you have any feedback. We appreciate your thoughts on how this went today. And I want to really give a round of applause to our presenters, Valerie, Nathaniel, and Tricia. Thank you so much. And with that, I think we'll end today's session.
Cool. Thank you, Jeff.
Thanks, everyone.